Welcome to my TV academic classes.
Hello student, today we'll discuss the numericals based on electricity. The formula that will be required to do the numericals based on electricity that I have written in the board. Now if you want, you can screenshot it also. The formulas are, now for the series connection, as we know that if the resistors are R1, R2 and R3, the equivalent series connection will be R1 plus R2 plus R3. That is in case of the series connection. Now in case of the parallel connection, that is this see here, R1, R2 and R3 are in a parallel connection and they are connected with a voltage say V. Then my equivalent resistance R1 will be equal to RP will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. So if there are n numbers of resistor, then 1 by R1 plus 1 by R2 plus 1 by R3 plus dot 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 up to n times. Now students, you know that in case of the parallel connection, what happens? The potential across each resistor remains same. So potential across is, it will be V, that V. Potential across R3 will be also V. Potential across R2 will also be V. So if I think that the current is here I1, here is I2 and here is I3. So the current I1 will be equal to this V divided by resistor R1. Okay. Now I2, that is the current through the second resistor, will be this potential V divided by R2. And in case of the third resistance, this is I3. I3 will be V divided by R3. So the total current, if I ask you what is the total current through it, this is I, then I will be equal to I1 plus I2 plus I3. Clear? This is in case of the parallel connection. So in case of the series connection, we know that R is equivalent is equal to R1 plus R2 plus R3. If it is of n terms, you can write R1 plus R2 plus R3 up to n terms. So in case of the parallel connection, that is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Clear? And the current to the first, this will be I1 is equal to V by R1. Why it is V by R1? Because in case of the parallel connection, the potential across each resistor remains same, that is V. So we know this in case of the Ohm's law, that is V is equal to I into R. So from I we get V by R. So I have applied this formula. So I1 is equal to V by R1. So I2 will be V by R2 and I3 will be my V by R3. Clear? Now, EMF. In case of the EMF, now if there is internal resistance, say R is the internal resistance. So what is the current? Current we know. The current is I is equal to E divided by R plus R. But why it is E divided by R plus R? See this one, this external resistance R and this internal resistance smaller, they are in series connection. So what is the equivalent resistance here? Equivalent resistance is R plus R. And so the current will be, that is E divided by R plus R. R is my external resistance and this smaller is my internal resistance. Am I clear? Now terminal voltage. Now what is terminal voltage? The voltage across the terminal. So this is voltage across this one, from here to here. See the resistor is here R. So terminal voltage will be my equal to I into capital R. That is the resistance across the external circuit. Am I clear? Now potential drop. Now what is potential drop? Potential drop is, that is given by I into this internal resistance, small r. This is the internal resistance. Or potential drop you can find by EMF minus the terminal voltage. Okay, it is clear. Is it clear to you? So potential drop is equal to EMF minus terminal voltage. Okay. So here is the first numericals. The question is, a battery of EMF 3 volt supplies current. Okay, this battery supplies current. A high resistance voltmeter is connected across the battery. The resistance is high, it is connected across the battery. Now when the current I 1.5 ampere passes. Now the voltmeter reads 2.7 volt. Now you have to find the internal resistance. So internal resistance is how much? It's very simple. So what we have find that the EMF of the battery is 3 volt. EMF means when no current passes through the battery. And when the current passes through the battery, now the voltmeter is 2.7. That means the potential drop is how much? Here the potential drop how much? Potential drop is equal to how much? Potential drop is given by the formula I into R, or this is equal to, that is my EMF minus the terminal voltage, that is 3 minus 2.7 volt. How much it is coming? That is 0.3 volt. So here R is the internal resistance, so that you have to find it out. What is the internal resistance? So we can write I into R is equal to 0.3, or I is equal to how much? I is equal to 1.5. So 1.5 into R is equal to 0.3. This out. So R is equal to 3 divided by 15. So this is coming around 0.2 ampere. So internal resistance is 0.2 ampere. Is this clear, bachcho? Internal resistance is 0.2 ampere. So here is the second numericals. There is a EMF of 1.8 volt, which have the internal resistance 2 ohm, and the external resistance there is 4.5, and it is connected with an ammeter. The ammeter having a resistance of 7 ohm. Now you have to find what is the current. I is equal to how much? The current is equal to how much? The first one. And second one, you have to find what is the potential difference across the terminal of the cell. That means this one, across this, from here to here, what is the potential difference? How to find it out? Now what formula we know? We know that I is equal to, we have discussed I is equal to E divided by R plus R. What is R here? R is here your external resistance. This is the external resistance, this one. This is connected in series connection. So capital R will be equal to my 4.5 plus 0.7. That is equal to how much? 5.2 ohm, capital R. And smaller, the internal resistance is how much? 2 ohm. So what is the value of R plus R? So R plus R is equal to 5.2 plus 2, that is 7.2 ohm. Clear? So my total resistance, that is internal resistance plus external resistance, is 5.2 plus 2, that is 7.2. So what is the current? Use this formula. So I is equal to E. E is how much? 1.8 divided by R plus R. What is the value of R plus R? 7.2. So how much it is coming? This is coming 1 by 4, or this is equal to 0.25 ampere. Clear? Don't write in the exam in the fraction, you have to write the decimal. So it is coming 2.25 ampere. So this, my current is coming around 0.25 ampere. Okay. This is the first part is over. Now second part, the potential across the terminal of the cell. Now what is the formula for potential across the terminal of the cell? That is terminal voltage, terminal voltage, this is part 2, terminal voltage is equal to I into capital R. That is the current into external resistance. And potential drop, we know potential drop is I into internal resistance, and potential terminal voltage is equal to I into external voltage. So that is I is equal to how much? 1 by 4. And how much we got the external resistance? External resistance is 5.2. So how much it is coming? So this is coming around 1.3 ampere. So the second part is potential drop across the terminal voltage is 1.3. Clear, Pacho? So now this is our the next question. Okay. Now see in the picture. These two are in the parallel connection. Now here is 4 ohm resistor. Here is 8 ohm resistor. The resistor of it, this is X and this is 5. Now you have to find the value of X. What is the value of X? It is given that the equivalent resistance of this system, equivalent resistance is 4 ohm. Okay. So how you need to find? Now to solve this one, see this one is series connection and this is also a series connection. Now so if I write it's R1, so what is the value of R1? R1 is equal to 4 plus 8, that is equal to 12 volt, 12 ohm, sorry. And what is the value of R2? This is R2. What is the value of R2? R2 is equal to 5 plus X. 5 plus X. Now what is the equivalent resistance given? Equivalent resistance is 4 ohm. See these two, this one and this one, that is R1 and R2. This is R1. Now it is coming in this picture. This is your R1 and this is my R2. R1 and R2, these two are in parallel connection. So what will be the formula? That is 1 by R equivalent is equal to 1 by R1 plus 1 by R2. 1 by R equivalent, that is for these two, this is when these two are in parallel connection. 1 by R equivalent is equal to 1 by R1 plus 1 by R2. What is given 1 by R equivalent? This is 1 by 4. So 1 by 4 is equal to 1 by R1. What is R1? 12. 1 by 12 plus here it is 1 by X plus 5. So 1 by X plus 5 is equal to 1 by 4 minus 1 by 12. How much will be the value of 1 by 4 minus 1 by 12? That is 12 is LCM. 3 minus 2, that is 2, or it is 1 by 6. So 1 by X plus 5 is equal to 1 by 6. So how much is X plus 5? X plus 5 is equal to 6. Therefore, X is equal to 6 minus 5, that is 1 ohm. So the value of X will be 1 ohm. Is it clear? So the next question. See, this is the circuit. This is 1 ohm, one resistor, and 2 ohm is the another resistor. These two resistors is connected which either series or parallel. Yes, it is in series connection. Now this thing is connected with a EMF, that is 2 volt. Now the question is, what is the current through each resistor? So let us think the current through the 1 ohm resistor is I1 and the current through 2 ohm resistor is I2. So I1 and I2. So how will find the value of I1 and I2? We know that in case of the parallel connection, the potential across each resistor, this is, and this two is same. The potential across this is how much? This 2 volt. And potential across this is how much? 2 volt. So I1 will be how much? I1 is equal to, use the Ohm's law. That is V is equal to I into R, or I is equal to V by R. So I1 is equal to, this is my V by R, that is 2 divided by 1, that is 2 ampere. And I2 is equal to 2 divided by 2, that is your 3 ampere. Sorry, this is equal to 1 ampere. It is clear? So if you have been asked, so what is the total current? So total current is equal to 1 plus 2, this is equal to 3 ampere. Is it clear? So total current is equal to my 3 ampere. So this is the next question. Okay. See the circuit. Now the voltage across is, it is V is equal to 4 volt. Here is an ammeter, and this ammeter is 0.4 ampere. That means the current I is equal to 0.4 ampere. Now these two resistors, this is unknown resistor R, and this is your known resistor, this is 20 ohm. This is R ohm and this is 20 ohm. These two, obviously you can see these two resistors are in parallel connection. Now your question is, what is the total resistance? What is the total resistance of this system? That means this, what is the total resistance? This one. And number two, what is the value of this R? What is the value of this R? And number three, what is the current flowing through this resistance R? Okay. So how to find the value of the total resistance? How to find? The total resistance is very simple. That is, from the Ohm's law, we know that V is equal to I into R. So I is equal to V by R. So total resistance I is equal to V by R, or R is equal to my V by I. So equivalent resistance RE is equal to V divided by I. That is, what is the value of V? V is 4 volt. And I is equal to how much? It is written 0.4. So how much it is coming? That is 10. 10. So equivalent resistance of this system is 10 ohm. So this part is over 10 ohm. This is equivalent resistance. Now you have to find the value of R. R का value कितना? अभी R का value निकालना पड़ेगा. So how will find the value of R? What formula you use? Should we use R is equal to R1 plus R2, or 1 by R is equal to 1 by R1 plus R2? Yes, that is the correct one. 1 by R is equal to 1 by R1 plus 1 by R2. So we can write here that 1 by, this for part 2, 1 by RE, that is equivalent resistance, is equal to 1 by, this is 20. 1 by 20 plus 1 by R. Now what is equivalent resistance here? 1 by 10. So 1 by 10, take it this side. 1 by 20 is equal to 1 by R. So now if you subtract it, we will find this is equal to 1 by 20 is equal to 1 by R. So the value of R, is equal to your 20 ohm. So this value, resistance is equal to 20 ohm. Now the third part, what is the value of I? I is equal to how much? How will find? So we know that the potential across this one and potential across this one is same, that is equal to 4. So I is equal to, I can write I is equal to this V, that is 4 divided by R, that is 4 divided by, what is the value of R? This is 20. So how much it is coming? This is coming 1 by 5, that is 0.2 ampere. So I is equal to 0.2 ampere. Clear? So this is the next question. See the circuit. Now here the EMF is 2 volt. Now internal resistance is given, it is 1.2 ohm. Now this is connected with an ammeter with a resistance of 0.8 ohm. And see, here is a circuit. This is parallel circuit, it is there. One is R1 and R2. That is R1 is 4.5 ohm and R2 is 9 ohm. So we have to find what is the value of reading in A. So reading, what is the reading in A? That means what is the value of I? I is equal to how much? We have to find what is the value of the I through this system. Then number 2, we have to find what is the terminal voltage. That means the potential across the external circuit. Terminal voltage means potential across the external circuit, and potential drop means that is the potential in the internal voltage. And then the potential difference across the 4.5 ohm, this one. So first we will find what is the reading, ammeter reading. So how we will find which is the formula? The formula we will use, that is I is equal to E divided by external resistance plus internal resistance. We know the internal resistance is 1.2. So we have to find the external resistance. To find the external resistance, this one and this one. These two are in series connection and this is in parallel connection. So to find what is the value of this one, that is 1 by equivalent resistance of R1 and R2 is equal to 1 by 4.5 plus 1 by 9. How much it is coming? 9. This is 2 plus 1, that is 1 by 3. That means equivalent resistance R12, equivalent resistance of Rn1 and 2 is coming around 3 ohm. Okay. So what is the value of R? Total external resistance. Total external resistance R is equal to, this is 0.8, this is the ammeter reading, plus this reading, plus 3. This is around 3.8 ohm. This is the value of external resistance. And what is the internal resistance? Internal resistance is 1.2. So what is the value of R plus R? R plus R, this is 3.8 plus internal resistance is 1.2. So this is equal to 5 ohm. Clear? So what is the value of I? Ammeter reading will be how much? So we can use this formula. I is equal to, that is E divided by external resistance plus internal resistance. How much it is? What is the value of E? This is 2. 2 divided by how much? 5. 2 by 5. This much ampere, or this is coming around, how much it is coming? 2 divided by 5, 20, this is 0.4. 0.4 ampere. So this is the value of I. So the ammeter reading is, this is 2 by 5, or this is 0.4 ampere. Now the second one, terminal voltage. So what is the terminal voltage? The second one, terminal voltage. Terminal voltage means the potential across the external resistance. So what is the external resistance? External resistance is your total, this one, R. This is the external resistance, 3.4. Okay. So terminal voltage, the terminal voltage is equal to, that is I into R. What is the value of I? That is 2 by 5 into R, that is 3.8. So this value is coming around 2 by 5 into 3.8. This value is coming around how much? This is coming around 1.52. 1.52 volt. So this is your terminal voltage. Clear? So the last part is potential across 4.5 ohm. This is potential across this one. Now how to find the potential across this one? So what is the equivalent resistance here? Equivalent resistance of this one, how much we got? Equivalent resistance? Equivalent resistance of 1 and 2, how much we got? Equivalent resistance? That was equal to 3. So the potential across this is equivalent resistance. The potential across this will be, that is will be voltage, potential voltage V will be equal to I into R. What was the value of I? I was your 2 by 5. 2 by 5 into R. This is the equivalent resistance is 3. That is 6 by 5. So this coming around 1.2 volt. Clear? So this is equal to 1.2 volt. So this is the next question. So before doing this question, I request you to subscribe my channel and give a big thumbs up to my to this one, and share it to all of your friends so that everyone will be benefited. And please write in the comment box if you want any other topics, numericals, so that I will make a video and I will upload in the YouTube. Okay. Now this is the question. This question is, this is the circuit. Here is the one ammeter. The ammeter gives a reading for the current, and see there one is resistor is R1 is equal to 6 ohm. This is your 4 ohm. This is your 3 ohm. These three are connected in this way, and this is the potential is V. Now you have to find what is the effective resistance, and number 2 you have to find what is the ammeter reading. Okay. Now see, this one you will do by yourself. I have given you the answer also. That is 3 volt and this is 2 volt. That's one clue I am giving you. That is this one, this R2 and R3 is in series connection. R2 and R3 in series connection. In series connection. And this 1 by equivalent, 1 by R1, R2 and R3 will definitely equal to 1 by R2, R3 plus 1 by R1. So you can find what is the resistance from here. So once you find the resistance, you divide it by the potential. So you will get the and you will get the reading in the ammeter. Clear? So you do it. And one more thing, once again I am telling you, if you want any numericals of any other chapter, please write in the comment box. I will upload the numericals on this chapter. Okay? Thank you.